Okay, we're gonna wrap up day 3. I can't believe how much we've done over the last few days. I'm told that we're gonna have a demo from the DevNet store, so I'd like to invite you to come do your demo first.
So while Jim is setting up, a quick announcement again. So we achieved 3 clients internally right now. So thanks to Camille, he managed to fix all the bugs now, and so 3 is able to talk to you and see, and so all the times I'm talking to you, so it's finalizing now.
Yeah, it's incredible. I mean, it shows that we put good foundations, from the beacon chain where we can just reuse the P2P, reuse the data.
Yeah, so my name is Jun from Ring Team, and I'm gonna show you a quick, about 2-minute demo for current DevNet. And quick disclaimer, in current DevNet 0, we don't have the post-quantum signature integrated. We are planning to integrate those after DevNet 1, but I think DevNet 0, the main focus for DevNet 0 is literally interrupting between 3 client teams. So from Qlin and Zine and Ring. So this is just a simple Docker compose script, and we have 6 nodes, which consists of two for each client team. So 2 Ring node, 2 Zine node, 2 Qlin node. And yeah, I can show you real quick. Maybe I can clean up. Yep. So I quickly generated Genesis, and with this Genesis, the DevNet will speed up. And yep. Alright, 6 nodes are now started, and we can just quickly look at what's going on right now. So there's a 6 nodes, and there's another containers that are under construction version of the Explorer for the leanVM. So we are waiting for Genesis, -5, -4, yep, 16 seconds left. Yep. And we are using a slightly modified 3SF mini written by Vitaly a few months ago for the consensus. And now we have Genesis is started. It's hard to see some logs, and maybe we can wait a few seconds to get it finalized. So you might see, just a second. All right, yeah. So we can see just this load from Zine team, and yeah. So we are getting finalized, specified, which is very cool. And I can show you a real quick about the leanVM app, which is an Explorer. So it's just a simple dashboard. So yeah, so we have 6 nodes, and there's a round robin for block producing, so which is just a modular 6 for each slot. And yeah, so for lean 0 and 1 is Ring is producing block as well. 3, 4 for Zine, 2, 3 for Zine, 4, 5 for Qlin. So yeah, I think it's going well. Let's go back to the log. Yep, it looks great, right? Yeah. Yeah, so I think it's now, it's very easy to, this is a cornerstone for integrating those post-quantum signature and also snark aggregation. So yeah, I hope this can accelerate this leanVM. Thanks.
So 2 of the pillars of the leanVM are post-quantum and faster finality. And ironically, during the post-quantum workshop, we have the fast finality, but not the quantum. And just to give a little bit of context, today it takes about 15 minutes to get finality, and here is 3 slots, so 12 seconds. Massive improvements over what we have right now. And the part of the thinking for Ethereum is that getting to 3SF or even 2SF is something that will be extremely difficult to do incrementally, hence why it makes sense to batch it with the post-quantum upgrade, both of which are very invasive upgrades that require some significant refactors. Okay, anything else from the DevNet team that you'd like to talk about? Raul, any peer-to-peer networking updates?
Not specifically. I think yesterday perhaps, like we've been throughout the week considering different approaches for broadcast and the different layers. And yesterday I think we kind of like put all the pieces together as well, chatting with Justin and drawing it all out on the board. And I think we scoped out an initial prototype of what a skeleton protocol would look like with 8 subnets, 1,024 validators per subnet, 10% of them being aggregators, and with a specific protocol for exchanging and enumerating with signatures, and aggregates would be available at each point in time. And all of this goes coupled with a rolling or /streaming pipeline where aggregates are being constantly produced and emitted for then the next layer of aggregators to pick the best match, to continue rolling them into aggregates, to then go and emit a global best match. And all of this would be happening in a streaming fashion, which means that both the networking layer and the protocol layer need to be very close together so that we're not leaking performance along the way. And this, of course, percolates into specific design decisions as well in the networking stack. What you should expect in the next days is a skeleton of a spec that basically outlines the basics of this protocol so that implementers can go and implement it initially on Liquid2B using a very thin profile of Liquid2B to then continue optimizing from there.
Nice. We also had this session on keygen in the morning. And basically, just to recap the problem, we have a lot of secret key material, potentially gigabytes of material, which is the fully expanded secret key for all of the one-time signatures. And there is basically this optimization, which seems to be quite simple, where we basically just cache the middle layer of the tree, which is of size square root, so it's just a couple megabytes, and we will recompute in real time the relevant pieces for a segment of slots. And the amount of storage that we need is about 2 megabytes, and the recomputation time is about 1 second for the whole 3 days. So every 3 days you spend 1 second of CPU time to generate the key. So that's a great outcome. Okay, next up we have the formal verification. Alex, any? Yes.
So I think for today, I think, because obviously we had some things to say this morning, so I think for today, I think it was quite interesting to see the different designs of minimal CKVMs and the discussion happened there. I think obviously how the CKVMs are designed actually can have quite a lot of impact in terms of how easy they are to formally verify. So that will be interesting to keep following. Poseidon 2 will be quite interesting. I think Poseidon 2, we're about to start formally verifying the Sputterfish version of Catch-MA in Arcade, and so we'll be quite excited to then plug Poseidon 2 into that and see what comes up. I saw there were some bounties and some interest in specifically Poseidon 2 in Catch-MA. So we'll keep an eye on that. I missed the earlier afternoon session. We were trick-or-treating with Giacomo, unfortunately unsuccessfully. And then Proximity Jam, I think, was quite interesting as well. I think we'll see what happens thrashing out into different conjectures that seem to be going on, and whether these end up in lean one way or another. But I think that's essentially very future work. But for the week as a whole, I think it was pretty good to, one, actually be able to gather a lot of people who are working on archive information in general into one room. Actually, I think it's the first time we've had that many people in the same room, which has been good. And to also see some new phrases as well as Banner presenting valid coding. And then I think a lot of what gets discussed is always very interesting for us because it's also been fully verifying, so having a better understanding of it and having a better understanding of the design constraints, which then feed back into different challenges for verification is also quite important for us. And so it's always good to do that, and it's always good to have people who aren't doing form verification have a look at what we're doing, because we typically always get good feedback and positive feedback, which is encouraging, of course.
Yeah, I mean, on the duplex front, it seems like there's also efforts to standardize this.
Yes, and KLA is trying to push this as an ITF standard and so on. So that's also why we're very good to get that one done in RTIP. Beyond the fact that actually it has proof to go down to the parametation, which also is quite attractive to transformers.
So we're trying to kind of push this as an industry standard and kind of do all the homework on the forward verification side of things.
Yeah, so hopefully pq3 adopts it and could formally verify the pq3 actually in a much easier way. But I think it's quite close already. So it should be fine.
And on the trick-or-treating, basically Alex studied mathematics here at Cambridge, and so he was knocking on Timothy Gauss's door and other people's door with the hope that we could nurse like them.
Yeah, so Timothy Gauss was not here, and then the other person who does information theory was not here, but I bumped into my old algebraic topology lecturer who said that Timothy Gauss will potentially be here tomorrow because it's the start of term. And so maybe, Giacomo won't be here. I'm supposed to be at the computer lab, but maybe we find some time to go and knock on his door again and try to get him interested. I saw him in June in Berlin, so in June in Edinburgh, so hopefully he maybe remembers me. He's going to call and say, well, I don't have a crying kid this time.
So one idea that Alex had is for one of the days next year to be in the Newton Institute. Which
we could do the whole week.
Or the whole week in the Newton Institute. And I'm told that they have whiteboards even in the toilets. The kids will productivity.
You know how to talk to us.
Okay, great. Next up, we have the implementers. Is Thomas here?
So yeah, this morning we had this interesting session about minimal ZKVM with a nice presentation from Clément and a lot of discussion happening there. So basically he presented us the paper of KOM detailing all of the details, how the memory works, everything, the different instructions. We found out some very interesting discussion also with Jim from Venus, discovering that this is kind of similar with the M3 arithmetization system, the way they handle things, and also a lot of synergy with the pq3 recursion project in the way they see the interactions between the various tables. Yeah, so this was quite a useful session. This will probably have like an important point in the future of the design that we could have in mind for the leanVM and maybe the future of leanVM. In the afternoon, we have also a very nice discussion with two presentations from Angus and Ruben from pq3 team and pq3 recursion. Angus did a very good overview of the current status of pq3, highlighting the strengths of pq3 that are, for example, like the current parallelization strategy or the current implementation of the small fields like koala bear or baby bear that are currently very well implemented in the finest details like SIMD optimization and stuff. And he also highlighted some points that could be improved, like for example, the transposition or the TFT algorithm. It shows also the numbers that we discussed the other days in comparing like the FFT with the number of operations that it should require without the FFT. So we found out that there is almost no gaps with small FFT, but some sort of gaps with larger FFT. So we plan also in the coming days and weeks to check this algorithm. And also we spoke about like the future of pq3 involving probably some multilinear things, weird, sun check, all of this. And we had finally a presentation from Robin about the pq3 recursion project, why they did this because they had all of the experience with pq2, with a very fast recursion things in pq2, and the way they handle like recursion via circuit builder. So taking this same approach and modernize it in order to be compatible with pq3. So yeah, very nice discussion on implementations today.
Very nice. Yeah. Yesterday I was having a dinner with Angus, Ben, and Clément, and one of the comments was that it's all M3 hidden, basically. The same optimization on the various flavors. Anyone else would like to talk about the implementers? Okay, if not, we can move to the theory with Evans.
Okay, so yeah, we had 3 sessions today, and I think it was a very intense day. So it started with Poseidon. We gave an overview of the history of Poseidon and where we are currently with the Poseidon initiative and cryptanalysis. I think one takeaway there is that we should maybe pick the constants for the following bounties in sort of coordination with pq3 and like how they do the constants to make sure that the constants that we pick for the bounties are representative. Yeah, then we had a session on the Winterlitz encodings, and I think this session started already during lunch because I was walking around and seeing people on whiteboards with hash chains and Dimitri explained the encoding to everyone, and then we had a very intense meeting on these encodings. I think there we had a lot of discussion on how to, if we change it like that, can we prove security still? No, we can't. How about this? And so on. And I think there's no definite conclusion, but the conclusion is we should talk much more about it. There are a lot of moving parts, and one of my concerns is that sort of the encoding gets more and more complex, and the sort of simplicity of hash-based signatures is no longer an argument. But I think the success here was that a lot of people who have not looked at the encoding before now know about sort of the problem and got nerves like. And then we had a session on proximity gem, which was a very open session, and Giacomo had essentially 2 ideas what to look at, and we split into 2 groups. One was about sort of the numerical analysis of these conjectures, and based on the script that Antonio already started. The other group was what is still there on the whiteboard, is like looking at the conjecture in very extreme cases, like what if you go as close to capacity as you can. And I think we made a lot of progress there that we now want to sort of write down in our belief to make sure we don't lose that. And yeah, I think that was a very great end of this whole week with a lot of theory sessions that were very successful.
Yeah, so we have at least one paper that was done again. But my hope is that we'll have actually several with the development of hindsight. And I'm told that after coffee, we will have potentially our first results from the simulations, which should be good. Giacomo, do you want to share a few words about your perspective on the progress?
Sure, I think like it's a very important work in the sense that understanding the regimes in which we can hope to prove something and not is very important. So we have some intuition that in this kind of like very dramatic thing there will be problems. This seems like to be warranted by the proof that we have with attacks, so this is very good. They still, we still don't have to do any security advisories because I don't think people, if you do the extra query for good luck, that part there doesn't really matter. But this is very, very good to figure out what we cannot prove. And also I'm really excited to see the numerics, where like and some beautiful like new things about parameter estimation. So we actually can like start thinking where actually to go and try to disprove the conjecture numerically. So then hopefully if these two things converge, we should be able to get like some much broader understanding. One of the things I want to add is like, you know, these two bars will also talk to each other, because when we're trying to prove these kind of things, you end up having like other vibes. The vibe like statement should be true, but then maybe we don't know how to prove them true, and luckily we have like numeric where we can like try and check this out. So I think synergy between the attacks, the proofs with gaps, and the numerics would be very good in us understanding more about the projection.
Nice. And that will help us, I guess, define the rules of the proximity price, so that we don't do something silly that is like immediately this blue here.
Yeah, and make it harder for others to win $1 million.
Right.
First we make them shoot all their salvos today, so that it makes them harder for later.
I see. I've also been, chatting with Neil quite a bit, and I know there have been like so many optimizations that have been found over the last few days. Do you want to share some of the top optimizations, Neil? No.
There are some things to share, but.
But I guess you have a laundry list of like 10 or 12 optimizations, and hopefully those compound each other and will lead to very significant speedups. Anyone want to share some?
Yeah, so actually something that's been extremely useful this week has also been hearing more details about, I guess, WIRE 2.0 and kind of FRI 2.0 with mutual correlated agreement Nico has been working on. And so it's been very nice to have these explained to us in person, because then we can actually upstream these into RClip and make our life easier because they're better constructions. And so thank you to them in particular.
Yeah, one thing that I heard is that thanks to the mutual correlated agreement, we have a much simpler proof of FRI, and that will make the formal verification so much simpler. So yeah, having Nico in the room maybe saves 100 man hours or man days or whatever, which is a great outcome. And I'm trying to think of some of the ZKVM optimization, but basically like removing some of the twiddles, like what else do we have? Okay, anyway, I had to hold this out. I'm happy to share it in Telegram chat. Any final words from anyone? One of the disappointments is that the college visit unfortunately can't happen because the portal is not available, but we will have a visit tomorrow at 2 p.m. So anyone who's still around, you're more than welcome. You're also welcome to just visit the village in small groups or on your own. And tonight we have the very special dinner that I've been talking about. So I'll see you around 6:30 for some drinks, and then the talk which will start around 7 p.m. Thank you so much, everyone, for listening.